wondered how your Wi-Fi connects, how planes detect objects in the sky, or even how your microwave oven heats your food? Well, welcome to the world of microwave engineering. In this short video, we'll break down what microwave engineering is, why it's important, and where you see it in action every single day. So, what exactly are microwaves? Imagine the electromagnetic spectrum as a superhighway of energy waves. On one side, you've got low-frequency radio waves. On the other, super-fast X-rays. Microwaves sit right in between, fast, powerful, and packed with energy. These high-frequency waves play a massive role in modern technology, from communication networks to radar systems and even medical applications. Got a text? That's microwaves at work. Whether it's 5G, Wi-Fi, or satellite signals, they all rely on microwave frequencies. Ever seen those huge rotating radars at airports? Yep, that's microwave technology helping pilots navigate safely. And in medicine, microwaves are used for cancer treatment and even for imaging inside the human body. Of course, let's not forget the most famous microwave application, your kitchen microwave oven. Now, let's talk about the cool tech that makes it all happen. Microwave engineering uses special components like waveguides to guide signals, antennas to transmit and receive, and amplifiers to boost weak signals. A waveguide is like a superhighway for microwaves. Unlike regular wires that struggle to carry high-frequency signals, waveguides ensure microwaves travel with minimal loss and maximum efficiency. But why not just use regular wires? Well, at microwave frequencies, traditional wires suffer from significant energy loss due to a phenomenon called the skin effect. On top of that, the signals can radiate out and leak, not ideal for clear and reliable communication. Waveguides solve this by keeping the microwave signals confined and guided. The microwaves reflect off the conductive inner walls, efficiently transferring energy from one end to the other. It's like light traveling through a mirrored tunnel. From radar systems and satellite communication to microwave ovens and scientific testing, waveguides are used wherever reliable, high-power microwave transmission is needed. Curious about how microwaves are shaping the future? Microwaves are the backbone of modern communication, enabling everything from mobile networks and satellite links to radar systems and wireless internet. Their ability to transmit large amounts of data over long distances with minimal interference makes them essential in today's interconnected world. Think about how we stay connected, whether it's making a video call, streaming your favorite show, or navigating with GPS. All of these rely on microwave technology. And as we move toward smarter cities, autonomous vehicles, and the ever-expanding Internet of Things, the role of microwaves will only grow.